This is the review for quiz 1. This is obviously after quiz 1, but I wanted to complete the video record. So let's go over the material for quiz 1, which will help prepare for the final exam. So first thing was the converting units. We can use the substitution method. We have two, let's say, kilometers per hour. We want to convert to meters per second. We can take kilometers, convert that to 1,000 meters, and we take hours, we convert that to 3,600 seconds, and we just make the replacement. 3,600 seconds, 1,000 meters. And then you divide as needed, multiply as needed to get 0.55 meters per second. Now if we have 15 kilometers squared, converting to meters squared, then we have to take the kilometers, convert that to 1,000 meters, but because kilometers is squared, the 1,000 meters has to be squared, so we get 15 times 1,000 times 1,000. So we get 1.5 times 10 to the 7th meters squared. Review of trigonometry, so we have an angle theta here, here is the right triangle, we have the opposite side, the adjacent side, and the hypotenuse. So sine of theta is opposite of the hypotenuse, a over c. So then A is equal to c, the hypotenuse times the sine of theta. The cosine is the adjacent over the hypotenuse, b over c. And so b is equal to c, the hypotenuse times the cosine of theta. Okay, vectors have magnitude and direction, a plus b. The addition of vectors by drawing, so let's say a looks like this, b looks like that. Then we take the first vector, a, we start from here, draw the first vector, and then we draw the second vector, b, starting from the end of a. And then if we go from the very start to the very beginning, that's the addition a plus b. If we want to define the negative of the vector is the thing you add to a to get 0. You just basically reverse the arrow, okay, with the same length. Now, a minus b means you are going to do a plus the negative of b. So we have a this way, b like this, and negative b looks like this. So we take a, the first vector, starting from here, and then we tack on negative b, and then go from the very start to the very beginning, and that gives me the vector a minus b. Okay. Now, vector components. But most of the work we do with vectors is done by breaking vectors into components. So we have the vector component ax, ay, that's the x component, the y component. And the vector itself, the length of the vector, the magnitude of the vector, is this hypotenuse, which is the square root of the sum of the squares, a squared plus ax squared plus ay squared. So in terms of trigonometry, ax is the adjacent side for theta, so ax is equal to a cosine theta. Ay is the opposite side, so it's a sine of theta. And then the tangent is the opposite over the adjacent, so ay over ax. And theta is equal to tangent, inverse tangent, or arctangent ay over ax. Okay, so remember there is one caveat with this inverse tangent. Sometimes you have to be careful whether you need to add or subtract 180 degrees to your answer. And you figure this out by just simply drawing the triangle or the vector involved, and that will tell you whether you need to add or subtract 180 degrees. That's actually what I say here. Sorry. So if you measure theta counterclockwise from the x-axis, we can use the simple fact that ax is equal to a cosine theta, ay is equal to a sine theta, and the theta is the inverse tangent or tangent of ay over ax. But must be careful with the inverse tangent, because tangent of theta is equal to tangent of theta plus 180 or tangent of theta minus 180. So you might need to add or subtract 180 to your answer if you count what it gives. So for example, if ax is minus 5, ay is minus 5, then we have this sort of direction here. Theta is clearly something like 200, more than 180 degrees, but less than 270. Okay, and so we can calculate a is the square root of ax squared plus ay squared, so square root of 50. That comes at 7.07. And theta is equal to the arctangent of minus 5 over minus 5. That's ay over ax. And we can get either 45, which is this angle, that's not the right direction, but we can add 180 degrees and get to 25, and that's exactly what we need. Any questions? Please ask the student supervising today's lecture. And so you can get some practice on writing down the x and the y components. Ax is 10 cosine of 30, ay is 10 sine of 30. Okay, in this case, ax is 10 sine of 30. 10 is the length in all of these cases. Ay is 10 cosine of 30. Now, in this case, ax is in the negative direction, so it's minus 10 because it's opposite sine of 30. Ay is going to still be positive 10 cosine of 30. Ax is going to be positive 10 cosine of 30. Ay is going to be negative, because it's going in the negative direction, 10 sine of 30. Okay, Ax is going to be negative 10 cosine of 30. Ay will be negative 10 sine of 30. In this case, Ax will be negative 10 cosine of 30. Ay will be positive 10 sine of 30. Last two cases, Ax will be positive 10 sine of 30. Ay will be negative 10 cosine of 30. Ax will be, in this case, will be negative 10 sine of 30. Ay will be negative 10 cosine of 30. Okay, now suppose we wanted to add vectors together. Here's an example. Vector A has magnitude 15 meters. B has magnitude 10 meters. The directions are indicated in the diagram below. Find the magnitude of A plus B and the angle C makes with the positive x-axis measured counterclockwise. Okay, so A looks something like this. B looks something like this. These are given. Okay, so we are going to get the components of A. We have 15 for the length here. We're going to get the AX component. It will be minus 15 because it's in the negative direction times the cosine of 20 because it's the adjacent side. That's negative 14.1. AY will be, because it's going in the positive direction, it's positive 15 times the sine of 20 because it's the opposite side. That comes to 5.13. BX will be in the positive direction here. It will be 10 times the hypotenuse times the sine of 30 because it's the opposite to the 30-degree angle. And that's 5.0 meters. And by is in the negative direction, and that'll be 10 times the cosine of 30 degrees because it's the adjacent side, minus 8.66. So now what we do is we add the components together. The x components are added together. Minus 14.1 plus 5 is minus 9.1. And the y components are 5.13 plus negative 8.66. That comes up to negative 3.53. To get the magnitude, you take the sum of the squares and then the square root. So we have the square root of minus 9.1 squared plus the square of minus 3.53. And that comes out to 9.76. And then to get the angle, first let's just make a sketch. It's pointing in this direction. Okay, so theta will be between 180 and 270. Get tangent of theta is equal to minus the y component over the x component. So we'll have minus 3.53 divided by minus 9.1. And so we get either theta is equal to 21 or 201. And it's clearly this one that we want, 201. If you have any questions, please ask the student supervising today's lecture. Okay, now we talked about motion along the x-axis. So we have a displacement delta x is equal to x minus x0. Final position is x, initial position is x0. Delta t is t minus t0, the final time minus initial time. So for the average velocity, the x average is delta x over delta t. Now this is, if we want to calculate average speed, in this course we didn't really do much with this, but it's the total distance traveled divided by the total time elapsed. This is not that useful. Okay, but if we want to know the instantaneous velocity, Vx is equal to the limit as delta t goes to 0 of delta x over delta t, or the time derivative of x. The instantaneous speed is just the magnitude of the instantaneous velocity. Now in a one-dimensional motion along the x-axis, it is just, the magnitude is just taking the absolute value of Vx. The speed is just the absolute value of Vx. In 2 dimensions, for the instantaneous speed, we have to do the square root of the sum of the squares, Vx squared plus Vy squared. And by default, when we say velocity, we mean the instantaneous velocity, and by speed, we mean the instantaneous speed, not this funny thing, average speed. Okay. Now, if we have a plot of position versus time, if we have x versus t, we can read off several things. So the slope here gives us the velocity, instantaneous velocity, delta x over delta t. So the rise is 2 meters, the run is 2 seconds, so it's 2 over 2 is 1 meter per second here. And in this region here, the slope is 0, so vx is 0. This region here, the slope is minus 2 over 2, so that's minus 1. So the instantaneous velocity is the slope of the position versus time plot. Okay, just getting the slope of this plot. Now the average acceleration is delta vx over delta t, so that's a change in the instantaneous velocity, vx minus v0x, the initial velocity. The instantaneous acceleration is the same quantity, but taking the limit delta t goes to 0, and that gives the time derivative of vx with respect to the time derivative of vx. And so if we want to to carry along the derivative definition of vx, that's the time derivative of x, then we have ax is the double time derivative of x. Okay, now if we have a plot of the velocity versus time, we plot velocity, then the slope here is the acceleration, the instantaneous acceleration. We have 3 meters per second, rise over the run is 1 second, so 3 meters per second squared. Here the acceleration is 0 because it's 0 slope for the velocity curve. And then for this region here, the slope will be negative 3. Okay, drops 3 rungs by 1. So the slope is going to be the instantaneous acceleration, the slope of the velocity versus time plot. Now we also can calculate delta x as the integral of the time derivative of x integrated with respect to time. That just gives the change in x. Okay, so that will be the integral vx from t initial to t final, t0 to t. So delta x, the displacement, is the integral under the velocity versus time plot. So for example, from 1 to 5, we can calculate the area of this triangle. 3 is the height times 5 minus 1, 4 is the difference here. That comes to 12 meters. From 0 to 1, this is a triangle, 1/2 the base times the height. So we have 1/2, 1 second times 3 meters per second for the height, and that comes to 1.5. And from 5 to 6 seconds, it's again 1/2 base times height, or 1/2 1 times 3 meters per second, and that's 1.5 meters again. Okay. If you have any questions, please ask the student supervising today's lecture. Next topic is constant acceleration in motion. So we'll write it for the x direction, but it works the same way for the y-axis motion. So delta t is the time interval, x0 is the initial position, x is the final position. X minus x0 is what I call delta x. v0x is the initial velocity, vx is the final velocity. Then we have these 5 formulas. vx is equal to v0x plus ax plus delta t. This is one of the important ones. Vx average is 1/2 vx plus v0x. This is not so widely used. Another one is x minus x0 is 1/2 vx plus v0x, quantity delta t. This is also not used very much. But these next two are used a lot. X minus x0 is equal to 1/2 ax delta t squared plus v0x delta t. This involves delta t, so if you need something with t involved, use this one. If you need an equation without any t because you don't know delta t, you don't want to know delta t, then use this one, vx squared, or v final squared minus v0x squared, or v initial squared, is equal to 2ax times delta x, or x minus x0. So what you do is you gather all the quantities you know and the one unknown you want to find, and then you pick an equation that contains your unknown and only things you know. Alright, now we can apply this for falling object. We take delta at y to point straight upwards, acceleration due to gravity on the surface of Earth, and as ay is equal to negative 9.80 meters per second squared. So we write ay is equal to negative g, where g is positive 9.80 meters per second squared. There's no minus in the definition of g. Let's finish with an example. A ball is thrown straight up in the air with the speed 10 meters per second. How long does it take for the ball to hit the floor, which is 2 meters below its initial height? Okay, so we have y minus y is 0, so this is y0, y is 2 meters below, so y minus y0 is minus 2.0 meters. And v0y, it's being thrown up with 10 meters per second, so it's positive 10 meters per second. Ay is pointing down, so it's negative 9.80 meters per second squared. We want to know delta t, so we pull out the formula that involves these things and delta t, and there's one formula that does this. Y minus y0 is equal to 1/2 ay delta t squared plus v0y delta t. Plug in the value, y minus y0 is negative 2. We have 1/2 ay is negative 9.8, and we have the delta t squared plus v0y is 10 meters per second times delta t. And then we can just simply rearrange things. 1/2 times negative 9.8, bring it to the other side is 4.9 delta t squared. Bring this to the other side, minus 10 delta t, and this stays there, and negative 2 is minus 2, and then that's equal to 0. And then we use the quadratic equation, ax squared plus bx plus c is equal to 0. The solution is x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. And so delta t will then be this minus b, which gives me plus 10, plus or minus the square root of minus 10 squared, that's b squared, minus 4a, a is 4.9, c is negative 2, divided by the square root of 2a, a is 4.9. And that comes out to 10 plus or minus 11.8 divided by 9.8 seconds. And so we get either minus 0.18 or 2.2 seconds. The minus 1.8 is actually, if you think about extending this backwards in time, that would be the point where it crosses 0 again, before the beginning, but that's unphysical. So the time we want is at positive 2.2 seconds. If you have any questions, please ask the student supervising today's session.